Alright, welcome back, boys and girls. It's your main math man, Mr. Shank, coming to you live from Summit Academy. In this video, we're going to be working on unit number 5, lesson 14, getting close to the end of this unit, and we're going to be talking about volume still. And so our lesson objective for today is we will be able to find the dimensions of a cylinder when given the volume. And so the first one that it has in there is, it says a cylinder with an unknown height. It says what is the possible volume for this cylinder if the diameter is 8 centimeters. So some things to remember. Again, we need the radius. So when you have the radius, it's going to be equal to the diameter d divided by, let me write that a little better, d divided by 2. So all we have to do to get the radius is take 8 divided by 2. So we have 8 divided by 2, which is going to be 4. And we can label that on our picture as well. We can say, okay, the radius is from the center out to the edge, and so we're going to say R equals 4. So even though we don't know the height, we can kind of talk about that here in a second. So what we're going to say is, we're going to say the volume is going to be equal to the area of the base, meaning big B, and the height, H. So make sure you remember, so let me label these parts. This is going to be volume, and this is going to be area of base, and this is going to be your height. So if we find our area of the base first, we can actually get on the right track. So I'm going to say, trace the base, redraw the base. So I'm going to draw a little circle here, and I'm going to say, well, we need to find the area of the circle with a radius that is 4. So when I go to find that, I'm going to say big B is going to be equal to pi times the radius squared. So we're going to say that it is going to be equal to, we're going to say B equals, big B equals pi, and then we have times 4 to the second power, which means we have, this is the same as 16 pi. All right. So now what we can do is we can plug that into our formula. And so we're going to say, all right, if we have volume, say volume equals, we're going to say 16 pi, because that's our big B, our area of the base, times H. And so if we want to, what we can do is we can say, well, if H equals 1, we're going to say volume is going to be equal to 16 pi, let's say, centimeters cubed. Or we can say, if we wanted to let if we want to say pi, let pi equal 3.14, we can multiply that out and we would still get volume equals, we'd say 50.24 centimeters cubed. Any of those would work out if we let the height be that, or if we said the height is 2, we would just multiply by 2. Either way, it still works out. All right, on the next one, it says the volume of the cylinder with height 4 is 36 pi cubic units. So it's giving you that this right here is going to be the volume. Again, a key word that we have from that is the cubic units, meaning units to the third power. That just tells us that it's going to be the volume. And so we're going to say that H is going to be 4. We can also see it in our picture here as well. So it says this statement is true. So it has 36 pi equals radius squared times pi times 4. So it says, what does the radius of this cylinder have to be? So what we can do is we can use this information that we're given to be able to solve for our unknown value. So we're going to say, if we have, and looking at this section here, we can say, hey, that this is going to be, let me circle it in blue. We're going to say this right here is going to be the big B, meaning the area of the base. So what we can do is we can separate that and be able to solve for our different parts. So what we can do is this. Let me actually... Alright, so sorry, I skipped this one. Let's actually go back and say, alright, so for 14.2, it says what's the dimension? It says the volume V of the cylinder with radius R is given by the formula, V equals pi times the radius squared times H. And what we know is, we know that this first part is going to be that big B, meaning the area of that base. So this is the big B. And it says, for number 1, it says the volume of the cylinder with radius 5 is 50 pi cubic units. So it's saying here is going to be R, and this is going to be V. So then it says this statement is true, meaning this equation is going to be B equals B, big B times H. So we know that this first part, that 5 squared times pi, is going to be our area of our base. So it says, what does the height of the cylinder have to be? So we can solve for H. So we're going to say solve for dimension, meaning either radius or height, using inverse operations. And so what we can do is we're going to set up that original equation that we had. So it says 50 pi is equal to 5 squared pi times H. And what we can also do is we can rewrite this, because we can do 5 times itself, because this is the same as 25. So we're going to have 50 pi equals 25 pi times H. And so what we can do is I'm going to divide both sides. I'm going to divide both sides by 25 pi. So divide both sides by 25 pi. 5 pi, and because what we can do is, if we divide that out, we're going to say this is going to be equal to 2, and the only thing remaining on the right side is going to be H. So our height is going to be 2 units. So we're going to say the height is 2 units. So notice again how your units are to the first power, because we're talking about length. If we were talking about the area of the base, they would be units squared. And if we were talking about the volume of something, we would be saying it's going to be units to the third power, or cubic units. All right, back to that number 2. We're talking about the same kind of thing. However, now we're finding the radius. And so I'm going to set up the same thing. I'm going to say, all right, I have 36 pi equals radius squared times pi times 4. So what we can do, divide both sides by a common amount. So I'm going to divide both sides by 4 pi, or pi times 4. And so what that means is I'm going to have on the left side, this is going to be equal to 9, and the right side, this is going to be equal to r squared. Get rid of that exponent, I needed to take the square root. So I'm going to take the square root of both sides. I'm going to say that's going to be 3 equals r. So our radius for this one is going to be equal to 3 units. So notice how we're able to use those inverse operations in red to be able to divide and then take the square root, or divide and then just get the height. And then for the next part, it says each row of the table has information about a particular cylinder. So it has the picture, notice how it has diameter going the whole way across, and radius is going to be from the center out, and then you have the height. So what you need to be able to do is, we need to be able to fill in some of these missing pieces. So for example, that first one, it gives us the radius, and again, remember, if I need the diameter is the 2 times the radius. So all I have to do is I say 2 times 3 is 6, and that's going to be my diameter. Then for the area of the base, well, that's just going to be, again, area of the base is big B equals the radius squared times pi. And so what we can do is we can say, well, if my radius is 3, I have 3 squared is going to be 9, and I have to be multiplying by pi still. So our area of the base is going to be 9 pi. And then lastly, all I have to do is multiply these two together. So I say for volume, that's going to be equal to volume equals area of the base times h. So I multiply these two together. So I'm going to say this is going to be 45 pi. So notice how I'm able to, just use one of these parts to be able to solve for the others. So let me keep going. So let me say for if we have the diameter is 12, that just means the radius is going to be half of that. So we're going to say it's 6. Then we're going to say the area of the base is going to be 6 times 6. So we're going to say this is 36 pi. And then if our height is unknown, we just have to do 108 divided by 36 pi. So we're going to say this is going to be equal to 3. So now, again, make sure you can see, I can take, same idea, I can take and divide this out. So I can say, well, if I know the volume is 99 pi, I could say this is going to be 9 pi, because I could do 99 divided by 11 to get 9 pi. And then these two, if I look at how these two are set up, I know that these are similar, so I'm going to say this is going to be 3, and this is going to be 6 as well. Moving to the next one, if my diameter is 8, that means my radius is 4. Then I can find the area of the base as 4 times itself, which is going to be 16, and then pi. And even though I don't know the height, I can say, well, if my volume is still 16 pi, that means I just multiply by 1. So my height for that one is going to be 1. This one's a little trickier because we're going to have some fractions, but that's okay because all we have to do is take 16 pi divided by 100. We're going to say that's going to be our area of the base. I'm going to say this is going to be 16 divided by 100 times pi. So that means our radius is going to be the square root of those. So the square root of 16 is going to be 4. Square root of 100 is going to be 10. To get from our radius to our diameter, we multiply by 2. So I'd do 2 times 4 over 10, which is going to be the same as 4 over 5. For the next one, it has the radius is 10, so we double that to get our diameter. So we're going to say 20. And so for the area or base, it's just going to be 10 squared, which is 100, and then times pi. And then to get our volume, it said we have to do 20 over 100. So I'm going to say 20 over 100. And if we look at, since the diameter is going to be the same, I can say that the radius is going to be 10. That makes the area of the base also 100 pi. However, our volume is 314. So notice how we go from the area of the base to the volume. It's almost like we just multiplied it out. So that means that the height is going to be 1, because if we let pi be equal to 3.14, we know that it works out. And lastly, but certainly not leastly, we have some different values on this one. But what we can say is this. We can say, well, again, we would have pi times a squared is going to be the area of the base. That means a is going to be the radius, and 2 times a is going to be our diameter. So notice how I'm able to fill these parts in. Again, one row goes with each value. Alrighty, moving to the back, it says complete the table with all of the missing information about 3 different cylinders. So it gives us the diameter, and we have to find the area of the base. So what we can do is almost like make another part of this table here. So let me do that right here. I'll say that, if this is diameter, what we can do is we can say, well, the radius is going to be half of that. So the radius is going to be 2. That means that the area of the base is going to be 2 squared, which is 4 times pi. And our height is 10, so we have to do 4 times 10, which is 40. So 40 pi is going to be our volume. Same idea with the next one. I'm going to say our diameter is equal to 6. Half of the diameter is the radius, which is 3. For our area of the base, it's 3 squared, which is 9 times pi. And then our height, we don't know, but we can say, well, if we do 63 divided by 9 pi, so let me say 63 pi divided by 9 pi, that's going to be equal to our height, which is going to be 7. So if you need to do a little scratch work on the side like that, please feel free. And then lastly, for this table, we have, let's have this. We have the area of the base is going to be 25 pi, so we take the square root of 25. So we're going to say radius is going to be equal to 5. That means the diameter is going to be equal to 10. And our volume for that is going to be 25 times 6, which is going to be 150 pi. So make sure you can, separate that for yourself, make those points that you need. All right, for the next one, for number 2, it says a cylinder has a volume of 45 pi and a radius of 3. What is the height? So we need to be able to use the information given. So we're saying, okay, so let's write that formula down. So we're saying volume equals area of the base times the height. We have the radius is 3, and we're saying, volume is equal to 45 pi. So let's write in this information that we have. So we're going to say for this one, we have 45 pi is equal to, well, we have r squared, so we're going to say, r squared is equal to 9. So we're going to say 9 pi, because that's going to be the area of the base. Again, big B is equal to 9 pi. And then our height, we don't know, so we're saying that's going to be h. So all we have to do is going to be that one step, divide both sides by 9 pi. 9 pi. And so we're going to say this is going to be 5 equals h. So the height for this height is going to be equal to 5 units. Moving on to number 3, it says 3 cylinders have a volume of 2,826 centimeters cubed. Cylinder A has a height of 900 centimeters, cylinder B has a height of 225 centimeters, and cylinder C has a height of 100 centimeters. Find the radius of each cylinder and use 3.14 as an approximation for pi. So we don't have to draw these, but what we can do is we can set up our equation. So I'm going to say for A, I draw it right here. I'm going to say we have 2,826 is equal to, well, we're going to say pi times the radius squared times 900, because that is the height of that first one. So let me make this a little bit smaller. And we'll move it to the left here. Okay. So let's say, what are we going to do for our first step? Well, we're going to divide both sides by 900. Divide both sides by 900. And we're going to say, all right, on the left side, we have 3.14 equals pi times the radius squared. And the only number that would work out for that, well, we could divide both sides by 3.14, which we're going to use as the approximation for pi. So we're going to say r squared equals 1. That means r equals 1. So the radius for A is going to be equal to 1. For that next one, for cylinder B, we have same setup. We're going to say 2826 because that's the volume for each of them. Then we have its height is 225. So we're going to say, all right, we have pi times the radius squared times 225. So divide both sides by 225. And so we say we have, let's say we have on the left side, we have 12.56 equals pi times the radius squared. Divide both sides by 3.14 because that's going to be what we have for pi. And we're going to say on the left side, we have this is 4. On the right side, we just have r squared. Take the square root of both sides. Take the square root of both sides. And we're going to say r equals 2. All right. So now for the last one, for part C, I'm going to say pause for your turn. Again, be able to solve, use those steps, and check with me. All right, moving on to number 4. It says a gas company's delivery truck has a cylindrical tank that is 14 feet in diameter and 40 feet long. So we have to sketch the tank, mark the radius and the height, then how much gas can fit in the tank, meaning find the volume. Okay, so let's try sketching this out. So we're going to have, let's try to do a little gray. Well, actually, let's do it like this. We'll do pink or light pink. So we have, I'm going to have a cylinder on its side here. Draw out that cylinder. Have that dashed line in the back. And what you can do is, if you want to, you can kind of shade in. Actually, use the highlighter to shade in. Give it some depth. All right. So now it's saying to write your. Sure. So you have your cylinder, and what you're going to say is you're going to say, all right, if the diameter is 14, we're going to say the radius. So we're going to mark the radius. We're going to say r equals half of that, which is 7, and the height, h, is going to be 40. So now what we have to do, we sketched it, we have the part A done. So now we have to find the, so first let's find the area of the base. So we're going to say big B is going to be equal to pi times the radius squared. So we're going to say we have, let's have big B is equal to 3.14 times 7 squared. And if we multiply that out, we should get big B, our area of the base, is equal to 153.86, and we're going to say feet squared. We also need to be able to multiply that by the height, so we're going to say our volume is going to be equal to big B times h, so we're going to say volume equals 153.86 times 40 to be able to get that volume. So we're going to say all together that volume is going to be equal to 6,154.4 feet cubed for this one. So make sure you can sketch it, find the area of your base, then multiply the area of the base times your height to get the volume. And for number 5 at the bottom, it says, here's a graph that shows the water height of the ocean between September 22nd and September 24th, 2016. So it says, estimate the water height at 12 p.m. on the 22nd. So let's find that on the graph. So we have 12 p.m. on the 22nd. And we're going to say it's going to be about right here. So what we can say is, well, it's going to be about, let's say about 3.5 feet, because it's in between 3 and 4. So now for part B, it says how many times was the water height 5 feet? Find 2 times when this happens. So let's say, let me point these out. So on the graph it says, well, the water is 5 feet. So we're looking at this part of the graph. So we have 1, 2, 3, 4 times actually that it hits at 5 feet. Let me make that a little bit better. All right, so let's say about for these first two, let's say about 2 p.m. and 6 p.m. on the 22nd, so on 9/22, and then on the 23rd, so on 9/23, around 3 p.m. and 7 p.m. So notice how I'm using those values or using those lines on the x-axis to match up wherewith it has 5 feet on the y-axis. Then for part C, it says what was the lowest water, or what was the lowest the water got during this time period? When did that happen? So look for that lowest point in your graph. So you could say, well, that's going to be about right here. So we're going to say the lowest amount was about 0.3 feet, and that was around 11 p.m. on, let's say, the 22nd on 9/22. And it says, does the water ever reach a height of 6 feet? And if I look at my graph, that's up here, and I'm saying, well, no, the graph did not reach that. So we're going to say, let's do in blue, let's say, no, the highest the water got was about 5.8 feet. So it never quite reached 6 feet, but that's okay because we can write out what did happen. All right, and for the last part, for that X ticket, it says the cylinder has a volume of 12 pi cubic inches and a diameter of 4 inches. Find the cylinder's height and the radius. So be able to find those values like we did before in the other problems. Be sure to ask questions, and as always, super slam that subscribe button.